Database normalization is a method of storing data which is efficient and robust for storage and analysis. It has 4 key benefits, which is that it protects the integrity of the data. It reduces the amount of space needed to store the data and makes it far easier to maintain. It also makes querying the data far quicker. Let's look at an example. This is a table of sales. With the above in mind, can you see any problems with this layout of data? Okay, let's explore that in more detail. The first problem is that on 2 occasions we're storing the information that product number 80726 is electric doors and they're white. The problem with that is that if we come along and modify one of those rows in our database, there's a chance that we'll only modify one of them and not both. Hence, we're creating a problem with data integrity. Any attributes of product 80726 should therefore be stored in a different table. If our database administrator wants to point us in the direction of a particular transaction, without a unique identifier on each row, it's very hard for us to identify which row they're talking about. Third, by storing each date in a separate column, we create lots of meaningless zeros. If each date were in its own row, with only one column of sales, we'd only be storing 4 values. In summary, because this is a sales table, all the attributes in this table should describe the sale, and they should not describe the product. Let's take a look at what good data normalization looks like. Here we have what we call a sales fact table. So a fact table is a table which records a particular event or measurement within a business or organization. Each line represents a particular sale or summary of sales. So in this case, the sales of product number 80725 on the 31st of January 2019 were of a value of $192. And that's got a unique transaction number of 307, which allows us to identify that in our database. Notice that all my sales values appear in one column now, and the dates have a column of their own. All of the attributes within this sales fact table describe the sale itself. They describe what was bought and when it was bought. Below, we have 2 dimension tables. Dimension tables add description to the attributes in fact tables. The product dimension table adds description to each of the product numbers. We can see now that electric doors white is only written once in our product dimension table, which solves our data integrity issue. Each unique product ID only appears once. And secondly, we also have a date dimension table, adding description to each of the dates within our sales fact table. Having the year in a separate column like this will help us later on to slice and dice our data by year. So remember, sales fact tables contain the data that we measure about our business, whilst dimension tables add descriptions to the attributes in our sales fact table. You will find instances in the future where it makes sense not to follow these guidelines, but I would suggest trying to follow this best practice until you find a reason not to.